Earth has been building life for over 4 billion years, and for most of that story, things are quietly changing in the background. Species show up, spread, disappear, and the world keeps moving. But every so often, something happens that doesn't just remove a few species around the edges. It changes the whole direction of life on the planet. Entire ecosystems collapse, familiar animals vanish, and what survives has to rebuild the world from whatever is left. Those are the events we call mass extinctions. Most people are familiar with the big one, the extinction that wiped out the dinosaurs. But Earth has actually had mass extinctions throughout its history, 5 to be exact. Today we're going to walk through each one, what happened, what was lost, and what came after. But there's a reason people keep bringing them up right now, because once you understand what the last 5 looked like, it raises one bigger question. Are we starting to see the early signs of a 6th? Let's start by looking at the End Ordovician extinction. This extinction occurred around 443 to 444 million years ago, right at the boundary between the Ordovician and Silurian periods. It's the oldest mass extinction we're going to cover, and it set a pattern we'll see again. When the planet's climate shifts hard and fast, life struggles to keep up. What makes this one unusual is that it didn't happen all at once. There were 2 distinct extinction pulses, separated by roughly 1 million years. Across both events, about 85% of marine species may have been lost, making it one of the biggest mass extinctions in Earth's history. At this point in time, life was overwhelmingly marine. The land was still mostly barren. All the action was happening in warm, shallow seas, packed with biodiversity. So what were the life forms like in this period? Trilobites were everywhere. These armored arthropods crawled along the seafloor and had been thriving for tens of millions of years. Brachiopods, shelled filter feeders that look a bit like clams but aren't related, covered the ocean bottom. Corals were building reefs. Crinoids, long-stalked creatures that look almost like underwater flowers, swayed in the currents, filtering food from the water. And graptolites, colonies of tiny animals that drifted through the open ocean, filled the water column. These groups had dominated the Ordovician seas for millions of years. But during the End Ordovician extinction, all of them took heavy losses. The major groups survived overall, but each lost significant members. So what caused it? The evidence points to major climate change tied to an ice age. As ice sheets expanded, temperatures dropped, and sea levels fell dramatically. Water locked up in ice meant the shallow seas where most marine life lived started shrinking. The first extinction pulse lines up with this cooling event. Then, roughly 1 million years later, the ice age ended. The glaciers melted, temperatures swung back up, and sea levels rose again. The second extinction pulse lines up with this warming. Life that had adapted to the cold was now hit by rapid temperature change in the opposite direction. It wasn't just one catastrophe, it was the whiplash, cooling and then warming, habitat loss and then habitat flooding that made survival so difficult. And for 85% of marine species, it was too much. Now let's talk about the late Devonian extinction. This event happened around 375 million years ago, and unlike the End Ordovician event, this one didn't come in 2 clean pulses. It came in waves, stretched out over several million years. By the time it was over, roughly 70 to 85% of marine species had disappeared. The damage was concentrated in the oceans, especially in tropical shallow seas and reef environments. Most land plants and animals survived, So, what did the world look like at this point? The Devonian is called the Age of Fishes because this was when fish really took off. Jawed fish were spreading everywhere. Armored fish, called placoderms, dominated the seas. And the first lobe-finned fish, ancestors of all land vertebrates, were starting to appear. Coral reefs were thriving, built by corals and massive sponges. Trilobites were still around, though less common. And on land, something new was happening. Plants were getting big. Early forests were spreading for the first time in Earth's history. During the late Devonian extinction, ocean life once again took the brunt of the hit. Reef builders were crushed, reefs collapsed, and they didn't recover for around 145 million years. Trilobites lost major groups, brachiopods took heavy losses, and fish, despite it being their age, saw roughly 75% of species disappear. So what caused it? It was likely a combination of things. One major suspect is low oxygen in the oceans. When ocean water loses its oxygen, most marine life can't survive. There's also evidence of cooling, which would have killed off tropical species. Here's where it gets interesting. Those early forests may have played a role. Big trees were pulling CO2 out of the atmosphere, which can cool the planet. Their roots also broke down rock and washed nutrients into the ocean, fueling algae blooms that sucked up even more oxygen. Volcanic activity and a possible meteorite impact have also been suggested, but nothing's confirmed. What makes this extinction different is that it wasn't one catastrophic moment. It was a slow grind, wave after wave, hitting the oceans hard, while life on land kept moving forward. Next, we need to talk about one of the most massive extinctions, the End Permian extinction, also known as the Great Dying. And that name isn't an exaggeration. This is the worst mass extinction Earth has ever seen. It happened around 252 million years ago, marking the end of the Permian period and the start of the Triassic. There were technically actually two extinction events in the Permian. A smaller one hit around 260 million years ago, but the second one, at the very end, was catastrophic. And it happened fast. Geological evidence suggests it may have taken no more than 200,000 years, which, in geologic time, is a blink. By the time it was over, about 90% of all plant and animal species were gone. In the oceans, it was even worse. About 96% of marine species disappeared. Life on Earth nearly ended. So what did the world look like before this? By the Permian, life had spread across land and sea. The oceans were full of corals, brachiopods, bryozoans, ammonoids, and fusulinids. Trilobites, those armored survivors from hundreds of millions of years earlier, were already fading and likely went extinct just before the main event. On land, reptiles and amphibians were thriving. Insects were everywhere, including giant dragonflies like Meganeuropsis, with wingspans nearly 2.5 feet across. But the End Permian extinction hit everything. Marine animals in reefs and shallow waters were hit the hardest. On land, more than 2/3 of amphibian and reptile species were wiped out. Nearly 1/3 of insect species disappeared. And that's notable because this is the only mass extinction that greatly affected insects. Insects survive almost anything, but not this time. So what caused it? It's hard to say for sure, and it was probably multiple things at once. One possibility is an asteroid strike. Another is massive volcanic eruptions that released dust clouds, blocked the sun, and cooled the Earth. There's also evidence of oxygen loss in the oceans, suffocating marine life. Several causes may have hit together to create the perfect storm. What makes the end Permian extinction stand out is the sheer scale and speed. This wasn't a slow decline, this was catastrophic, and whatever survived had to rebuild life on a planet that had been almost completely wiped clean. Now let's talk about the End-Triassic extinction, also called the Triassic-Jurassic extinction. This one happened around 201 million years ago, wiping out roughly 76 to 80% of species. It ranks fourth in severity among the big five mass extinctions. But here's why this one matters. The End-Triassic extinction cleared the way for dinosaurs to take over. Before this, dinosaurs existed, but they weren't dominant. After this, they became the rulers of the land for the next 135 million years. So what did the world look like at this point? By the Triassic, life had mostly recovered from the end Permian catastrophe. The supercontinent Pangaea was still together, and the climate was generally hot and dry. In the oceans, ammonoids were thriving. Conodonts, small eel-like creatures, were still around. Marine reptiles swam through the water. On land, early dinosaurs shared the world with other reptiles, early mammals, and a variety of other vertebrates. The End-Triassic extinction hit the oceans hard. Ammonoids took severe losses. Conodonts were wiped out completely. Brachiopods, gastropods, bivalves, and some marine reptiles also suffered major losses. On land, a large portion of vertebrates disappeared. But here's the key. Dinosaurs, pterosaurs, crocodiles, turtles, mammals, and fishes were largely unaffected. That gave dinosaurs the opening they needed. Plant life, interestingly, showed no major change. So what caused it? The leading explanation is massive volcanism tied to the breakup of Pangaea. As the supercontinent started to rift apart, huge volcanic eruptions released massive amounts of CO2 into the atmosphere. This caused global warming of about 10 to 15 degrees Celsius and ocean acidification. The eruptions happened over about 620,000 years, with the first 40,000 years being especially intense. Other ideas have been suggested, like methane release or an asteroid impact, but the volcanism and CO2 release remain the strongest explanation. What makes the End-Triassic extinction important isn't just what was lost, it's what came after. Dinosaurs survived, and with their competition gone, they spread across the planet and became the dominant land animals for the rest of the Mesozoic era. Finally, let's talk about the End Cretaceous extinction, also called the KPG extinction. This is the most well-known mass extinction because it's the one that wiped out the dinosaurs. It happened about 66 million years ago, and about 75% of species went extinct. So what did the world look like before this? The Cretaceous was the age of dinosaurs. They had dominated the land for over 160 million years. Massive sauropods, fearsome theropods like Tyrannosaurus rex, herds of horned ceratopsians, all thriving across the planet. Pterosaurs ruled the skies. In the oceans, massive marine reptiles like mosasaurs and plesiosaurs were apex predators. Ammonites, those coiled shell mollusks, were everywhere. Dinosaurs seemed unstoppable. But the End Cretaceous extinction changed everything. All non-avian dinosaurs went extinct. Birds, which are technically dinosaurs, survived. Pterosaurs were wiped out. Marine reptiles like mosasaurs and plesiosaurs disappeared. Ammonites, after surviving multiple mass extinctions, finally went extinct. So what caused it? The evidence points to a massive asteroid impact. A rock about 6 miles wide slammed into what is now the Yucatan Peninsula in Mexico, creating the Chicxulub crater. The impact threw up a massive dust cloud that blocked out the sun. Photosynthesis collapsed, plants died, plankton died, herbivores starved, carnivores starved. Food chains failed from the bottom up. Hot debris sparked wildfires across the planet. Tsunamis and extreme climate changes followed. But there's debate about whether the asteroid was the only cause. Around the same time, massive volcanic eruptions were happening in what's now India, the Deccan Traps. These eruptions released huge amounts of gases that altered the climate. Sea levels were also falling, reducing shallow seas. Some scientists think ecosystems were already stressed before the impact, and the asteroid was the final blow. Mammals had existed alongside dinosaurs for millions of years, but they were small and kept in check by dinosaur dominance. After this extinction, mammals survived and expanded, eventually leading to everything from bats to whales to us. Without this extinction, we might not be here.
So that brings us to the question a lot of people are asking right now.
Are we in the middle of a sixth mass extinction? The short answer from scientists is most likely yes. Or at the very least, we're well on our way. And unlike the past 5 extinctions, this one isn't being caused by an asteroid, volcanic eruptions, or natural climate shifts. This one is being driven by us. Here's why scientists believe we're in a mass extinction right now. First, extinction rates are 1,000 to 10,000 times higher than normal. We're losing species hundreds or thousands of times faster than the natural background rate. Second, habitat loss is happening on a massive scale. We've converted 40% of all land on Earth for food production. Agriculture is responsible for 90% of global deforestation and 70% of the planet's freshwater use. Third, climate change is accelerating. CO2 is rising faster than at any point in Earth's history due to fossil fuel burning. Food production and consumption contribute significantly to greenhouse gas emissions, pushing temperatures higher and increasing droughts, storms, and climate extremes. Fourth, pollution is widespread. Air, soil, fresh water, and oceans are all being polluted at levels that harm ecosystems and species. And fifth, species are interconnected. Losing one can cascade through an entire ecosystem. Declining populations threaten the ecological functions we rely on, like clean air, clean water, healthy soils, and stable climate patterns. The past 5 mass extinctions reshaped life on Earth. Each one was catastrophic, but life eventually recovered. The difference now is that we're the ones driving it. And unlike an asteroid or a volcano, we have the ability to change course. Earth has been through extinction events before, and life has always found a way to bounce back. But recovery takes time, millions of years. After the dinosaurs went extinct 66 million years ago, it took millions of years for mammals to diversify and fill the spaces they left behind. The end Permian extinction nearly wiped out all complex life, and it took over 10 million years for ecosystems to stabilize again. Recovery happens, but not on human timescales. The good news is that we're not powerless. Scientists around the world are studying these patterns, tracking biodiversity, and working on solutions. Conservation efforts are expanding, renewable energy is growing, protected areas are being established, and more people than ever are aware of the problem and pushing for change. Understanding the past 5 mass extinctions gives us context for what we're seeing today. It shows us how resilient life can be, but also how fragile ecosystems are when conditions change too fast. The species we share the planet with aren't just background noise. They're part of the systems that keep the air clean, the water drinkable, the soil fertile, and the climate stable. Protecting them isn't just about saving wildlife. It's about maintaining the systems we all depend on. Thank you for watching. If you want to keep exploring prehistoric life, have a look at my recent videos on Titanoboa and Daspletosaurus. And if you'd like to see more videos like this, please consider liking and subscribing.